Yeah. So we'll be taking this as a u. If you want, you can take it as a u square also, because under root is there. So if you are comfortable with under root, fine. We'll be taking it as a u only. So what we'll be getting from here? We will be getting, after differentiation both side, we'll be getting here 2x plus 1, right?
Yes.
This this dx is equals to du. Okay, here if we will take out common 2 in our original integration, we will be getting 2x plus 1 in bracket. Okay, and here everything I am writing for now as it is. In the next step we will be doing the substitution. So we will be writing, either if you understand Annapurna, see, if you understand, you can write 2x plus 1 dx as a du. You can think that this 2x plus 1 and dx combined together became only du. If you understand like this, great. If it is creating confusion, then you can just write it in the denominator and then you can cancel out. Are you getting it, Annapurna? You can also write it like this. Dx is equals to du by 2x plus 1. Getting it?
Yes.
Okay. So 2, the constant you can keep out. Okay. 2x plus 1 dx, if you want, write it like this. 2x plus 1 dx, at the place of dx, just write it du by 2x plus 1. Okay. Eventually this 2 will get cancelled out. Either you think about absorbing it or you think about cancelling it, it will get cancelled. And this x square plus x plus 1, this will be under root u. Right, Annapurna?
Yes.
Now from here you will be able to do under root u du. You will be able to use the formula of x to the power n plus 1 by n plus 1, right?
Yes.
Okay, let's proceed. Now we have to do the integration of, another question is there, we have to integrate 1 by x minus root x dx. Again, if we have to think about what can be taken as a substitution. For now, think about it. This type of formula we don't have in our formula list, right?
Yes.
Okay. So this type of formula we don't have. That means we have to think about maybe substitution will work. So for substitution, the first thing we'll be thinking that what we will be taking as a substitution. One thing we'll be taking, another thing we'll be getting from here. So any idea, Annapurna, what can be done?
Can we separate it by 1 by x minus 1 by root x?
No, we will not separate it because the common denominator is this one. We can only separate when you are having, suppose you are having 5 plus z by x minus root x, then you can write 5 by x minus root x plus z by x minus root x, because these two are the same thing. But when you are having 5 by x plus y plus z, you cannot say it is 5 by x plus 5 by y plus 5 by z. We cannot say, think about it. Think about it. 5 by x plus 5 by y plus 5 by z means what? If we will try solving it, our LCM will be xyz, right?
Yes. Can we
Okay.
take root x as common?
Yes, of course. Okay, we will be taking root x as a common, and just after taking root x common, Annapurna, you will be able to identify that what can be taken as a substitution. So let's take root x common and tell me what will be remaining in the bracket.
Root x minus 1.
Now you tell me what to take as a substitution.
Root x minus 1.
Exactly. Getting it?
Yes.
Okay. Root x minus 1 is u. When we'll be, in our mind, we are very clear. If we'll be doing the derivative of root x minus 1, our result will be 1 by 2 root x. Right, Annapurna?
Yes.
Okay. And here dx is equals to du. So 1 by, if you want, you can, let's absorb it over here. 1 by root x we can see in our integration. Okay, 1 by root x is there and dx is there. This, the extra 2, that only we are shifting to another side. Here I am doing it directly. Okay, whatever way you are comfortable, please do it that way. So dx by root x we are already having, that means 2 du, that means 2 du, and 1 by root x minus 1 means 1 by u. Are you getting it, Annapurna?
Yes.
Okay, so basically we have to integrate this one, and please be careful, Annapurna, that after doing the integration you have to do the back substitution. You cannot leave your answer in terms of u. Just one more step you have to perform. You have to write there u means under root x minus 1. Getting it?
Yes.
Let's move. If we are having the integration of x by under root x plus 4, we have to do dx. Okay, then what can be taken as a substitution?
Root x plus 4.
If we'll be taking root x plus 4, or you are saying root x plus 4 or only x plus 4?
And then we can square it.
Okay, you want to take root x plus 4 as a u, and then you want to square both sides, so it will be just x plus 4 is equals to u square. That's what you said, Annapurna.
Yes.
And now we'll be doing the derivative. It will be dx is equals to 2u du, right?
Yes.
Let's check whether it is working or not. Okay, so the denominator became, the denominator under root x plus 4 is just u.
U.
Okay, and dx is nothing but 2u du, and x is what, Annapurna?
U square minus 4.
Exactly, x is u square minus 4. Okay, so this logic we will apply, since after taking one of the term we are not getting another term, but still our integration is becoming simple. We can see from here that it just became u square minus 4 du, and term by term integration we can do over here, right?
Yes.
Yeah, let's proceed. Suppose we are having the integration of x cube minus 1, 1 by 3, exponent is there, x to the power 5 dx. What we'll be having, Annapurna? What can be taken as a substitution?
X cube minus 1.
X cube minus 1, let's check it. X cube minus 1 as a u.
Yes.
So on the left hand side, we'll be having 3x square. Okay, dx is equals to du, right?
Yes.
Okay, so let's just substitute everything. Either you can take x square from here, or you can take dx is nothing but du by 3x square. Okay, let's try substituting it. X cube minus 1 is nothing but u. Okay, u is having the exponent 1 by 3, fine. Okay, x to the power 5 we will be keeping like this, and dx means nothing but, or you can take the, like, you can observe, you can try breaking this x to the power 5 as a x cube into x square, and you can try this absorbing this 3x x square dx. Okay, so you can do that way also, or you can do this way also. You can substitute that this is nothing but this 3x square, x square from here, x cube we ended up getting. What can be done after that, Annapurna? Because still our integration is not that simple. x cube we are still having. We need everything in terms of u so that we can go and we can do the integration. Can we write from here that x cube is nothing but u plus 1?
Yes.
Yes, we can. Okay, x cube is nothing but u plus 1. So sometime this type of question, uh, please don't sit and try, just try thinking that what can be done. If one of the term you are taking differentiation, another you are not getting, still go ahead and check it in the rough part. Keep on doing it. Maybe after doing the steps you will realize that yeah, it is becoming simple. The way you will realize for this particular question, can you see, Annapurna, it became simple. You when you will apply the distributive property, this u to the power 1 by 3, when you will multiply in the bracket, term by term integration you can do, right?
Yes.
Let's move. X square by 2 plus 3x cube, that's whole cube. Integration of that we have to do. What to do over here, Annapurna?
2 plus 3x cube as u.
Okay, you will be taking 2 plus 3x cube as a u. So derivative will be doing. Derivative will be
9x square.
dx is equals to du. Okay. X square we can see is still x square dx we are having. So you will be able to do this one, right, Annapurna?
Yes.
If we are having the integration of 1 by x log x to the power m, then what to do?
Log x as u.
Yes, log x is u. Derivative will be 1 by x. Dx is equals to du. We can clearly see 1 by x dx we are having. So basically we'll be having u to the power m, and here du will be there, which became very simple. Let's move. If we are having x over 9 minus 4x square, and integration of that if we have to do, what we'll be doing, Annapurna?
9 minus 4x square as u.
Perfect. 9 minus 4x square as a u. We will end up getting 9 will be 0 minus 8x dx is equals to du. X dx we are having. So minus 8 will not create confusion. We understand how to deal with this. Du by minus 8. Okay. X ds is nothing but du by minus 8. Okay. Or minus 1 by 8 you can write over u. And from here you will be able to continue, right, Annapurna?
Yes.
Let's move. Suppose we are having e to the power 2x plus 3, and integration of that we have to do. Directly also you can do this one, but if the instruction is use the method of substitution, then what you will do?
2x plus 3 as u.
Yeah, 2x plus 3 as a u, and it will just become 2 dx, so nothing extra will come, and you will be able to do. Okay, let's do the next one. X over e to the power x square dx if we'll be having, then what to do over here?
x square as u.
Exactly. X square as a u you will be taking. It will just become 2x dx is equals to du. X dx already we are having. X dx already we are having du by 2. Okay, let's continue. E to the power tan inverse x over 1 plus x square. If we have to do the integration of this one, then what we'll be doing?
Tan inverse x as u.
Exactly, tan inverse x as a u you will be taking, and the denominator will get absorbed. E to the power u du, something like that, you will end up getting the result, which you can do easily. Now, what about this one? E to the power 2x minus 1 by e to the power 2x plus 1. If we are having this, we have to do the integration of this function. Then what we'll be doing? What we will be taking as a substitution?
2x.
If we will be taking, wait, here dx was there. If we will be taking 2x as a u, okay, we will end up getting 2 dx is equals to du. So basically dx is nothing but du by 2. Okay, let me substitute everything. So we'll be having dx is nothing but du by 2, that means 1 by 2. 2x you have taken as a u, so e to the power u minus 1 by e to the power u plus 1. Okay, and du will be having, is it possible to integrate it?
No,
Can we take any substitution again?
no.
Okay, that way it is creating confusion. Let me let's do it another way. Okay, this is very special type of question where before starting to take the substitution, what we'll do from here also it is possible, but let me tell you what we can do instead of this one. We can, whenever you will be having such question, what we will be doing first, at first we will be dividing the numerator and the denominator with e to the power x. Okay, if we will be dividing, let me write it over here, dividing numerator and denominator in any function, multiplying the same term in numerator and denominator, dividing the same term in numerator and denominator, that is acceptable. So here we are just dividing numerator and denominator by e to the power x. Let's see what are we going to get, Annapurna. So if you will divide this 2x minus 1 by e to the power x, and the same thing if you will do with the denominator e to the power 2x plus 1 by e to the power x. Think about it. The numerator will become e to the power 2x by e to the power x will be e to the power x only. Yes or no?
Yes,
Are you getting it? 2x means e to the power x square. E to the power 2x means e to the power x square. Are you getting it?
yes,
Okay. That's why I am writing that it, since it was a square, so one of the e to the power x is remaining. And the other one will be minus 1 by e to the power x. That means minus e to the power minus x can be right, Annapurna.
yes,
Okay. Similarly, in the denominator, e to the power 2x by e to the power x will be e to the power x only. And again, plus 1 by e to the power x will become plus e to the power minus x. Okay. Dx. Now think about it. If you will be taking the denominator as a substitution, check it. What are you going to get?
E to the power x minus e to the power minus x.
So if we are taking the denominator as a substitution, automatically numerator we are getting, right, Annapurna?
Yes.
Okay, so this is a special type of function. Whenever you will be having such function, please try doing this arrangement. It will make our integration very simple. After that, you can take the substitution. You will be getting e to the power x minus e to the power minus x dx is equals to du. Now, at the place of e to the power x minus e to the power minus x dx, we can directly write it is nothing but du by u, and then you can do the integration by yourself, right?
Yes.
Let's proceed. What about these type of questions? When we are having tan square 2x minus 3, then what to do? If we have to do the integration of this one, whenever we'll be having such integration, Annapurna, what we will do, we will at first tan square is there. So let's convert this tan as a sec, because if sec square will be there, even if sec square whatever is there, sec square u will be there, we know what will be the integration of that. But do we know about tan square? No, right?
No.
Okay, so is it possible to convert it in sec? Yeah, we are having a relation, a identity you know already, that is sec square theta minus tan square theta is equals to 1, right, Annapurna?
Sec square minus 1.
Yes. Okay, so at the place of tan square we can write sec square, whatever is there at the place of theta, okay, whatever is there, that minus 1, okay, that dx. Any confusion so far, Annapurna?
No.
Okay, now we can use the concept of term function. So sec square 2x minus 3 we are having, okay, dx, and minus dx we are having. Now sec square 2x minus 3, if you want you can do it directly also, this 2x minus 3, then in the denominator you will be doing the derivative, or the substitution method we can use over here. Basically that method came from the substitution only. Can you understand that how you used to do the integration of sine 2x, and then 2x you used to do the derivative in the denominator? It just came from the method of substitution, right, Annapurna?
Yes.
Okay, so this 2x minus 3, even if you will be taking as a u, okay, nothing extra you will be getting, you will just be getting 2 dx is equals to du. That means dx is equals to du by 2. So you can take the substitution and you can continue from here, right? Getting it, Annapurna? Any confusion so far?
No.
Okay, this one you will be able to do, sine inverse one. Suppose we are having 2 cos x minus 3 sin x, okay, over 6 cos x plus 4 sin x, then what to do, Annapurna? Think about it just a second, no? Yes, Annapurna, are you able to do it? Can you hear me?
The denominator as u.
Denominator we'll be taking and we'll be getting the numerator, right?
Yes.
Okay, so it's that simple. You can also see that from the denominator common factor we can take. Okay, so if you want, you can take it here, or otherwise after doing the derivative you will realize. So we can take out 2 as a common factor and we'll be left with 3 cos x plus 2 sin x. If you will be taking this one as a substitution, directly you will be getting the numerator, right? Are you getting directly the numerator?
Yes.
Okay, so it's very simple. Let's do the next one. If we are having if we have to do the integration of 1 by cos square x and 1 minus tan x whole square, then what to do, Annapurna?
1 minus tan x as u.
Okay, 1 minus tan x as a u, and derivative will be
Minus sec square x.
exactly minus sec square x dx is equals to du. So basically we are having sec square x dx is equals to minus du. Do we have sec square x in our integration?
Yes.
Yes, we do have. Okay, let's continue. Cos root x by root x. Here what to take as a substitution, Annapurna?
Root x.
Exactly, when we'll be taking root x as a u, we will end up getting 1 by 2 root x and our integration will become very simple, which we can see already. Let's move. If we are having the integration of x plus 1, x plus log x is square over x dx, then what to do, Annapurna? What to take as a substitution? Any idea? Think about it.
X plus log x, which will give x plus 1 by x.
What we'll be taking as a substitution?
X plus log x.
So x plus log x, if we will be taking the substitution as a u, we will be getting 1 plus 1 by x, right?
Which is x plus 1 by x.
Exactly. Okay, which is just x plus 1 by x. Okay, x plus 1 by x is nothing but 1 plus 1 by x. This, that's what you are saying, right?
Yes.
Yeah. So like this, you have to sit, you have to observe, you have to analyze. If observation is not working, okay, then you have to try whatever is coming in your mind. So this we are having sine tan inverse x to the power 4 over 1 plus x to the power 8.
Tan inverse x to the power 4 as u.
Exactly, tan inverse x to the power 4 as a u if we will be taking. Then what will be the derivative, Annapurna?
One by x to the power 4 into 4x cubed.
Tan inverse x formula was?
Oh, 1 by x to the power 8 plus 1.
Was it 1 by 1 plus x square?
Yes,
Okay. So 1 plus whatever x is there, that square will be writing, right, Annapurna?
yes, that is x to the power 8.
Yes, which will be x to the power 8. And then x to the power 4 we will be doing by chain rule.
4x cubed.
Getting it? Chain rule. Okay, you have learned that the the function looks like this, and if you have to find the derivative, then yes, you can use the formula, but whatever you are taking just as a x, again you have to do the derivative of the same. So the question is, can we apply chain rule here? Yes, we can apply chain rule everywhere, wherever we will be trying doing the derivative. If product rule applicable, if quotient rule applicable, if chain rule applicable, whatever will be applicable, we will be using it, right?
Yes,
Yes. So it will become 1 by 1 plus x to the power square. That is the derivative of. And then x to the power 4 derivative by chain rule will be 4x cube. And you can see now everything got absorbed, right?
yes,
Is it crystal clear?
yes.
Now we are done with the method of substitution. Okay, let's do this one also. Why to leave one or two question? 10x to the power 9 is there. Then 10 to the power x log 10 base e is there, divided by x to the power 10 plus 10 to the power x dx is there. Please tell me quickly.
We should take the denominator as u.
When we'll be taking the denominator, automatically we'll be getting the numerator. Right, Annapurna?
Yes,
Okay. Now, the last one, if we are having dx over sine inverse sine square x cos square x, what we'll be getting? How to do the integration? Any idea? Think about it. Let's think about all the possibility. Okay. So here, if you will be taking the denominators cos square, it will not work, right? Will it?
yes,
Okay. Let's think about it. If we are taking, suppose we are taking cos x as a u. Okay. So we will be getting the derivative of cos x is minus sin x. Okay. Instead of cos x, since minus sin is coming, let's try taking the sin x. We are checking, okay, not the final one. We are just trying to analyze what can be done. Let's think about all the possibilities. So sin x is u. Suppose we are assuming like this. So what we will be getting, cos x dx is equals to du, right, Annapurna?
yes,
Okay. Now we don't have any cos x. Okay. So dx is equals to du by cos x. That's what we are getting for now. Okay, one already we can see one cos x is there, one more cos x in the denominator. That means, do we want to say cos cube x will be there? Let's think about it. Let's think that whether it will work or not. Okay, so we can write this dx as a du by cos x. Okay, sin x we are going to write as a u square, and cos square x as it is we are writing for now. For now, as it is we are writing. Now, can we say that this is nothing but cos cube x in the denominator?
Yes.
Okay, in the denominator. If we will try using the sine formula, then we have to write like this 1 minus sin square x. But it seems like our everything, this substitution, the integration will become more tricky, right?
Yes.
Okay, it will become more tricky. Okay, now suppose we are taking 1 by sine square x means cosec square x, right?
Yes.
Let's see. Do you know the formula that, have you learned this formula in class 11, Annapurna? Sine 2x is 2 sine x cos x.
Yes.
Okay, so what about if we will be taking, if we will be taking 1 by 2, okay, 2 by 2, okay, 2 we are multiplying, 2 we are dividing, this denominators 2 will be taking in the integration. So not 2, 4, okay, because the square is there. So can we write like this, that 4 dx by 2 sin x cos x whole square? Can we write it like this? Can we?
Yes.
Which eventually become dx by sin 2x whole square, right? That means, do we want to say that we will be having cosec square 2x? Yes, we do. Is there any formula for this one? Are you getting it, Annapurna? Are you getting it? 1 by sin x means cosec square x, cosec x, right?
Yes.
Okay. So do we have any formula for this one?
Yes.
Okay. So this is how we'll be doing it. Is it clear, Annapurna?
Yes.
Okay. So here we did little bit of we applied actually this question. It We can also do this question by converting this sine square x as a cos square x, and then we can think about it what can be done. Okay, 1 minus cos square x, and then here cos square x. Okay, then we can think about it. We'll be taking the substitution, so many things will come, we will be getting, but better, it is better to use the identity, and it is becoming so simple. And now only we are going to discuss this part, that how to use the trigonometric identity to simplify our integration. So that is the next part over here. First, you learned how to do the basic integration, which is exactly like the formula. We were just using the formula and nothing else. Then you learned that, yeah, we can also use the method of substitution, when one of the term can be taken as a substitution and automatically we'll be getting the another term after doing the derivative. Such integration, if we are having, method of substitution works always. Okay. Now the third type, which you have seen over here, this one. This one, again we are doing the integration, but here we are using the identity. And now so many integration will be, you will be learning how to do the integration, how to simplify the integration by using the identities. So another question is, here nothing new you are learning, identities you already know, right, Annapurna?
Yes.
I'm just going to show you that how identity will make our integration simple. Okay, let's do it. Now the question is why it is there in the method of substitution then. Now you can take this 2x as a u. Okay, it will become 2 dx is equals to du. Okay, then you can just do the integration of cosec square u du. Getting it?
Yes.
Suppose we have to integrate, just focus. Suppose we have to integrate cos square x dx. Here we cannot say, please don't say that we can use chain rule. We can say it will be cos 2 plus 1 by 2 plus 1. That is for derivative. Okay, chain rule we are having for derivative. For integration, we cannot use chain rule. You know that, right?
Yes.
Then how we'll be doing the integration over here? Identities. Okay, we will be using the identities. You understand, in our formula sequence, in the series of formula, we are having how to find the integration of sin x dx. We are having how to find the integration of cos x dx, and so many other formulas also we are having. Instead of sin x, even if we will be having just sin 2x, we know how to do the integration directly. Also you have learnt in the first exercise, right Annapurna?
Yes.
Okay, that this 2x again you can do instead of 2x 4x also you will be having, you will be able to do the 4x again in the denominator, right? So
Yes.
you realized that angle can be anything. It can be x, it can be 4x, it can be x plus 2, it can be x by 2, it can be x by 3. So angle can be anything, but this sign must be signed, then only we will proceed with doing the integration, right?
Yes.
Okay. Now here we are having cos square x, it is having power 2, then we are not able to use the formula. So what we will be doing, do you know a formula of cos 2x where cos square x is involved? Do you know, Annapurna? Do you know the formula of cos 2x which was
Yes.
cos square x minus sin square x? Do you know this?
Yes.
Okay. The next formula was 1 minus 2 sin square x, right Annapurna?
Yes.
And the next formula was 2 cos square x minus 1. Is it so?
Yes.
Three formulas we were having. Okay, cos square x you can see over here. The third formula we are going to use. How we'll be using the third formula? Little bit of customization we'll be doing in the third formula. What we are going to write that okay, cos 2x is 2 cos square x minus 1. That means 2 cos square x is nothing but cos 2x plus 1, right Annapurna?
Yes.
Okay, that means cos square x is nothing but cos 2x plus 1 by 2, right Annapurna?
Yes.
So we'll be substituting cos 2x plus 1 by 2 at the place of cos square x. Any confusion?
No.
Let's write it. Okay, now term by term integration we can see, we can do this denominators too, we can just keep it out 1 by 2, and we'll be doing the integration of cos 2x dx plus 1 dx, that means only dx. Any confusion, Annapurna?
No.
And now only we were discussing that angle can be anything. We know the method of substitution, and we also know that directly also we can do it. Okay, directly also we can do the integration of cos 2x. What will be the integration, Annapurna? cos x का इंटीग्रेशन क्या होता है?
sin x.
Sin x. So cos 2x will be sin 2x, but in denominator you will be doing the derivative of 2x, that is 2. Yes or no?
Yes.
Method of substitution you can use. From there also you will be getting the same. Or directly also you can do, because here it's not that tricky. Just 2x is there, right?
Yes.
Okay. Now the next one is just x. And we got our answer, of course, plus constant of integration. Okay. We got our answer. Is it clear, Annapurna?
Yes.
So have you learned something new? No. Inverse trigonometric function in that chapter, you have used the identities for solving, simplifying so many questions, right?
Yes.
Okay. So here we are not doing something new. Are you learning a new way of doing the integration? No. It is not a new way of doing the integration. It is just the way you already you know it, right?
Yes.
Okay, so that's why in the first class I said to you the new ways, the method of substitution, the new ways, the partial fraction decomposition. These are the new way. Okay, let's do a few more questions. Suppose we have to do the integration of sine 2x cos 3x dx. Yeah. Then what to do, Annapurna? Do you know these formulas? I'm going to show you something new. Okay. You must have seen the formula of sine c plus sine d, sine c minus sine d, okay, 2 sine c cos d. That formula have you seen?
Yes.
What will be the formula, Annapurna?
Sin 2x plus 3x.
Just give me a moment, no? Yeah, tell me.
Sin x plus y
Okay,
plus sin x minus y.
exactly. Okay, both will be sine sine. Let me check. You are saying that if you will be adding sine x plus y formula and sine x minus y formula, okay, that means you must have learned this way in class 11, right?
Yes.
Okay, and if we will be adding this two equation, yeah, we can see that this one and this one will get cancelled out. Yeah, we'll be having sine 2x plus 3x, that is 5x, right?
Yes.
Okay, and plus 2x minus 3x, right?
Yes.
2x minus 3x is sine of minus x we'll be having over here. Do we know that sine of minus theta is minus sine theta?
Yes.
Right, Annapurna?
Yes.
Okay, so we are done, right? Sine 5x minus sine x dx, of course. We are done, right?
Yes.
Okay, let's move. You know that how to do the integration of sine 5x, right, Annapurna?
Yes.
Okay, let's do other questions. Let me see which one you cannot do. That will we can discuss over here. So the first one, second one. This type of question you have done already while doing the simplification, I believe, or what? Cos 2x, cos 4x, cos 6x. Yes, Annapurna. Here also we'll be taking two at a time, right?
Yes.
Okay. One thing we have missed writing in the previous question. Can you see that if you will be adding this two, we will be getting here 2 times sin x cos y, right? Right?
Yes.
So 2 was not there. Either at first only you do the multiplication of 2, division of 2, or towards the last you have to write 1 by 2. That means this 2 you are shifting to another side, right? Am I making
Yes.
sense? Okay, so be careful, 1 by 2 will be there. Now what about this one? Can we do, can we take this two together? Let's try. Okay, maths is all about trying. Whatever is coming in our mind, we must try it. Then only you will learn it. Okay, properly. So can we take cos 2x, cos 4x together? Yes, maybe. Okay. Then if we will be taking cos 2x, cos 4x together, okay, here only if you want to multiply 2, divide 2, you can do so. You can do so. Okay. So 2 cos 2x, cos 4x. Then what we will be having, Annapurna? What was the formula?
Cos x plus y plus cos x minus y.
Exactly. So we'll be having cos x plus y, that means 6x, plus cos x minus y, that means just cos x, 2x. Negative sign will get absorbed with cos, right?
Yes.
Okay. Now sines, this cos 6x is still we are having. So what? We will be writing it. That's what you are learning over here. How to use the identities. If we will apply the distributive property, here we will be having cos square 6x. And here we'll be having cos 2x into cos 6x. For the second part, again we can use the For the second part, again we can use the same concept, same logic, right, Annapurna?
Yes.
What about the first part? The same formula, cos square 6x is there. So for cos square x, this is the formula, right? This is the formula, right?
Yes.
When angle will be 6x instead of x, so here also angle at the place of x, it will be 6x. Okay, right? That means do we want to say cos 2 into 6x? That means 12x plus 1 by 2. Yes, we do. Getting it?
Yes.
Okay, cos 12x plus 1 by 2, which is very simple to solve. We know how to solve it. Okay, how to do the integration of this cos 12x plus 1, okay, by 2. We know that. And what about the other one? Other one, we can still use the same formula. A plus b, a minus b, right?
Yes.
Okay. So please do it now and tell me the final answer. Do it, Annapurna. Do everything. Just copy. If you want to do from the very beginning, the question was just this one. And final answer, please tell me. Okay. This was the question that cos 2x we were having, cos 4x we were having, cos 6x we were having. Please do the integration step by step and tell me what you got as an answer. Okay. Are you done, Annapurna? Yes. Are you done?
Almost.
Okay, you are doing it still?
Yes.
Do it.
Done.
Tell me what you got.
1 by 2 into x by 2 plus sine 12x by 24 plus sine 8x by 16 plus sine 4x by 8 plus c.
Exactly. Okay. Yes, we'll be getting the same. Okay, let's move. Yes, one thing. After 1 by 2, you said 1 by 2, what you said? X by 2?
Yes.
From where you are getting X by 2? Okay.
The whole x by 2 plus sine 12x by 2.
Check it, no? Check your steps.
1 by 2 is out of the square bracket. The rest
Okay,
is
then whole
inside.
x by 2, right?
Yes.
From here, right?
Yes.
Yeah. Let's move. Let's do the just a second. Let me check which number we can do. Okay, if we are having this one, cos x minus sin x over 1 plus sin 2x dx. What to do over here, Annapurna? Think about it and tell me. After this one, we'll also be doing this one. In trigonometric, inverse trigonometric function, have you like this type of simplification we were doing? Can you see like 1 plus sine 2x, we can write it as a, the denominator we can write sine 2x as a 2 sine x cos x, right, Annapurna?
Yes.
And 1 can be written as, can we write 1 as a sine square x plus cos square x?
Yes.
Okay, so numerator will remain as it is. The denominator will become sine x plus cos x whole square. Yes or no?
Yes.
And the numerator was sin x cos x minus sin x. Okay. Now, any idea, Annapurna, what to do?
Substitution.
Substitution. The denominator you will be doing the substitution and numerator you will be getting it, right?
Yes.
Exactly. Okay. So this is how we have to use the identities, and along with that we are doing the substitution as well. Let's do the other one. Please think about it, the other one. Okay, I'm taking that which question, what is the next which can we can discuss. Yes, what to do in the next one, Annapurna?
Sine square x is 1 minus cos x, cos square x.
Then
Then this is an identity 1 minus cos x into 1 plus cos x.
exactly. Okay, so yeah, let's continue. What to do with this one? If we are having integration of tan cube 2x sec 2x dx, then what to do, Annapurna? Yes, think about it. Okay. Can we can we write this tan cube as a tan square and we can use the sec formula? Can we?
Yes.
Okay, sec square minus tan square is equals to 1. So tan square is sec square minus 1, 2x minus 1. Here still we are having sec 2x. Okay, and here we can take the same tan 2x. Now what can be done? If we will be taking, let me write it properly. If we will be writing this as a sec square 2x minus 1 is there, and what else we are having? Tan 2x, sec 2x dx we are having, right Annapurna?
Yes.
Okay, what is the, if we will be taking this sec as a u substitution, that sec 2x is there. Okay, that is if you will be taking the u, then after derivative what we will be getting Annapurna? Yes.
We're only taking sec 2x as u.
Okay, at first you want to take 2x as a u.
Sec square 2x as u.
So yes, if we are taking sec square 2x as sec 2x as a u, okay, what is the formula for derivative of sec theta?
Sec theta tan theta.
So that means if you will be taking sec 2x is equals to u, and if you will be doing the derivative on both sides, you will be getting sec theta tan theta, and by chain rule 2x again you will do. So only 2, that is equals to du by dx, right?
Yes.
We can see that sec theta tan theta is getting absorbed. Okay, 1 2 extra we are having, that will go in the denominator on the other side, and we are getting this as a u square minus 1 as it is we are writing. Is it making sense to you?
Yes.
Got it?
Yes.
Okay, so tan cube we are having. Okay, so we are thinking here only whether to take tan and then to get sec, or to take sec then to get sectan. So we are thinking to take the substitution here only. Okay. So once we applied the formula, once we have taken tan square as a sec square, we are able to do the substitution directly. And yeah, the integration is very simple now. Any confusion so far, Annapurna?
No.
Let's continue. Similarly, this one also you can do. If you are having tan to the power 4 x dx, then what to do? Annapurna, think about it and tell me. If we are having tan to the power 4x dx, then what to do? Whenever you are having sec tan, this all, okay, try using the formula, okay? The tan in terms of sec, sec in terms of tan, like that. Then what to do over here?
tan square x into tan square x.
Tan square into tan square. Perfect. At the place of tan square, we can write
Sec square minus 1.
like this, right? Or the other one you want to keep like that only? Or other one also you want to use the formula, the same formula?
Use the same formula.
Uh, can you please repeat?
Use the same formula, sec square x minus 1.
Which one you want to take as a u substitution, Annapurna?
Sec square minus 1.
Okay, this one you want to take as a u substitution. And the other one, this tan one, you want to keep as a tan or you want to keep as a sec?
Sec.
Okay. Now you want to take this sec square x minus 1. Okay, that u. So you will be getting here 2 sec theta sec x. Then by chain rule, it will be sec x into tan x, right?
Yes.
Is it making our integration simple? अगर यहाँ पे हमने दूसरे वाले tan को अगर हम tan ही रखते तो फिर क्या होता? चलो देखते हैं एक बार. ठीक है, अगर दूसरा वाला जो हमारे पास tan है उसको tan ही रखते हैं और जो पहला वाला tan है उसको sec में हमने ब्रेक कर लिया. ठीक है, अब अगर यहाँ पे हम सोचते हैं कि चलो देखो देखें क्या कर सकते हैं, तो हमारे पास कुछ ऐसा दिखता है sec स्क्वायर एक्स tan स्क्वायर एक्स माइनस इंटीग्रेशन tan स्क्वायर एक्स dx हमेशा हमें लिखना जरूरी होता है dx. ओके, जो सेकेंड वाला tan स्क्वायर एक्स है वो तो फिर भी समझ में आ रहा है कि यहाँ पे हम tan का फॉर्मूला यूज कर सकते हैं. ओके, okay, whole square will be there. Okay, and here we'll be having sec square x tan square x. अगर हम sec x अगर हम tan x को पुट करेंगे तो sec स्क्वायर x मिल रहा है. यहाँ हमें दिख रहा है कि अगर हम tan x को पुट करेंगे तो sec x मिल रहा है, राइट?
Yes.
ओके, tan x अगर हम u ले रहे हैं तो tan x का डेरिवेटिव होता है sec स्क्वायर x, राइट अन्नपूर्णा?
Yes.
तो ये वाला इंटीग्रेशन तो हमारा सिंपल हो चुका ऑलरेडी. नेक्स्ट वाला अभी भी हमें सोचने की जरूरत है कि हम क्या करें नेक्स्ट वाले में. ओके, क्या कर सकते हैं अन्नपूर्णा? एनी आइडिया? अगर हम नेक्स्ट वाले को भी tan स्क्वायर, ओके, tan स्क्वायर इज देयर, व्हाई टू गेट कंफ्यूज? डायरेक्टली वी कैन राइट इट इज नथिंग बट sec स्क्वायर माइनस 1, राइट?
Yes.
तो हमें कुछ और फिगर आउट नहीं करना है. ओके, आई थॉट देयर tan टू द पावर 4 is there, that's why I was writing one more as well. So yeah, we are done. Can you see अन्नपूर्णा?
Yes.
हमने क्या किया, अब हमारे पास tan टू द पावर 4 था. ओके, यहाँ हम फॉर्मूला नहीं यूज कर पा रहे. ओके, डायरेक्टली कोई इंटीग्रेशन का फॉर्मूला हम यूज नहीं कर पा रहे, तो हमने क्या किया, इसे tan स्क्वायर लिख लिया. ओके, यू सेड इट. After that, the first tan square we have written as a sec square x minus 1, and the next tan square also we tried. हमने try किया next वाले tan square को भी sec square minus 1 लेने की. Okay, then we found that it is not working. अगर हम sec square minus 1 को u लेते हैं सब्सटीट्यूशन, तो बहुत ही वियर्ड सा एक डिफरेंट सा हमें डेरिवेटिव मिल रहा है जो कि हमारे इंटीग्रेशन में है ही नहीं, राइट?
Yes.
तो हम ये तो बिल्कुल नहीं करेंगे, तो हमने सोचा कि चलो एक tan स्क्वायर को सेक स्क्वायर के टर्म में लिख दिया, दूसरे tan स्क्वायर को एज इट इज ही रहने देते हैं। और फिर हमने क्या किया, टर्म बाय टर्म इंटीग्रेशन करने, जस्ट डिस्ट्रीब्यूटिव प्रॉपर्टी लगा के अलग अलग कर दिया, टर्म बाय टर्म इंटीग्रेशन करने की हम कोशिश कर रहे हैं। तो हमें ये रियलाइज हुआ कि अब ये थोड़ा सिंपल हो गया। हमारा फर्स्ट वाला जो इंटीग्रेशन है उसमें क्या है, हमारे पास सी अन्नपूर्णा। यहाँ से हमें माइंड में एक और चीज अब रखना होगा कि जब भी सेक स्क्वायर tan स्क्वायर होगा तो हम उसको वहीं पे इंटीग्रेट कर सकते हैं। हम कह सकते हैं कि tan इज u एंड इट विल गिव सेक स्क्वायर x dx du, एंड हमारा इंटीग्रेशन बहुत ही सिंपल हो जाएगा, राइट। आज के बाद से हमारे माइंड में ये रहेगा कि अगर ऐसा कुछ इंटीग्रेशन में कहीं भी कभी भी दिखेगा तो हम उसे डायरेक्टली कर सकते हैं यू सब्स्टिट्यूशन की हेल्प से, राइट।
Yes.
Okay, same for the other, all the other things which we are discussing over here, that if we are having, अगर हमारे पास cos स्क्वायर x है, ओके, और मे बी कॉस स्क्वायर 6x है, और मे बी कॉस स्क्वायर वट एवर कुछ भी x है, हम cos 2x वाला फॉर्मूला कस्टमाइज करके यूज कर सकते हैं, राइट अन्नपूर्णा।
Yes.
ओके, सो ये सारी चीजें जो हम यहाँ पे देख रहे हैं ये हमारे माइंड में अब रहना चाहिए। और ये कैसे रहेगा, प्रैक्टिस क्लास के बाद यू हैव टू सिट विथ ऑल द क्वेश्चंस फ्रॉम यू सब्स्टिट्यूशन एंड फ्रॉम दिस आइडेंटिटी, एंड you have to solve each and every question by yourself, and then you have to tell me whether everything was clear or not. Okay, because when you will be proceeding with the integration, student को यही दिक्कत आती है इंटीग्रेशन करते टाइम, कि वो ये सब लर्न तो करते हैं लेकिन जैसे ही हम प्रोग्रेस करेंगे ये सब हम क्विक क्विक यूज करना शुरू कर देंगे, कि वहां पे हम ऐसे कर रहे थे तो यहाँ पे तो हमें पता ही है, ऐसे ही करना है। और एक न्यू कंसेप्ट भी सीख रहे हैं, ओल्ड वाला कंसेप्ट जो कि माइंड में ठीक से रजिस्टर नहीं हुआ वो भी यूज कर रहे हैं, तो इसीलिए इंटीग्रेशन बहुत ट्रिकी हो जाता है, बहुत टफ हो जाता है। आ रहा है समझ में?
Yes.
Okay, so you have to practice all this after the class. Okay, before the next class, please join. First, practice everything and let me know whether you have faced difficulty in any of the question. So I'm leaving it. You will be able to continue from here, right?
Yes.
Let's continue. अगर हमारे पास कुछ ऐसा इंटीग्रेशन है, जितने फॉर्मूलाज हमें आते हैं हम बैठ के कोशिश करेंगे कि उसको यूज करें, अप्लाई करें, क्या पता हमारा इंटीग्रेशन सिंपल हो जाए। ओके, और सिंप्लीफिकेशन भी जितना पॉसिबल है विल बी डूइंग। यहाँ क्या कर सकते हैं अन्नपूर्णा? ये तो बहुत सिंपल है, राइट।
Yes.
क्या कर सकते हैं? यस अन्नपूर्णा, व्हाट कैन बी डन?
We can separate it.
Yes, we can separate the term. That is the first thing which must come in mind. And yes, we will be try doing the same. Sine cube x by whatever is the denominator dx plus cos cube x by whatever is the denominator dx. Okay, then sine square gone, and we are just left with sin x and cos square x. अब क्या, इसके बाद क्या कर सकते हैं अन्नपूर्णा? यस, अब हमें ये दिख रहा है कि डेनोमिनेटर,
Cos square x
Yes.
Instead of cos square x, it can be 1 by cos x.
Okay. Okay, so it just became 1 by cos x. That means you want to tell me that it will be sec x and sin x by cos x will be tan x. That's what you want to tell me?
Yes,
Yes. Okay. And similarly, the next one also will be cot into cosec. Is it so?
yes,
Yes, it is too. Okay. Let's do this one. Cos 2x. Wait, let me drag. Yeah. Cos 2x plus 2 sin square x. Let me check the question first. Yeah, this is what we are. Yes, Annapurna, what can be done? You are trying it, try it. Are you doing it, Annapurna?
yes.
Do it.
Cos 2x is 1 minus 2 sine square x.
Perfect. Okay. Plus 2 sin square x.
It cancels out and becomes sec square x.
It just became very simple. You can see by using the identity, it became very simple, right?
Yes,
Okay. That's why the chapter you have learned that how to do the simplification. If I'll be giving you this question, that suppose we have to integrate sine inverse cos x, then what to do, Annapurna? if sine inverse of sine will be there, if this question will be from inverse trigonometric function, then you must be thinking that sine inverse sine will be there, then it will be great, right?
Yes.
Can we make cos as a sine?
Sine pi by 2 minus x.
Okay, sine pi by 2 minus x, and we are done. We are done. What we have to do the integration now? We have to do the integration of only pi by 2 minus x, right?
Yes.
And it became very simple. Okay, let's proceed. Suppose we are having 1 by sin x cos cube x, then what to do? Think about it. Are you doing it, Annapurna? Yes. Are you doing it?
I'm not getting it.
Okay. So let's try doing it. What can we do? You have you have tried all the possibility, taking cos as a sine, sine as a cos, whatever, right?
Yes.
Okay, let's think about it. Can we write the numerator as a sine square x plus cos square x? Can we?
Yes.
And if we will do so, can you see that it is becoming quite simple if we will now separate the terms?
Yes.
Let's see. Let's see still what we'll be getting. So we will be getting sine square over sine x cos cube x dx plus cos square over sin x. So the question is, now we have to think about all the possible arrangement which can work. Yes. Okay. Here we did one arrangement, and still we are on the way. We are checking whether it will work or not. So we are getting sin x by cos cube is there. Okay. Cos cube is there. You can write as a cos, and you can write cos square if you want. Here also we are having cos by not cos square cos cube gone, right? So we are just having cos by sine,
Yes.
that is cot. Yes or no?
Yes.
Basically we are, wait, we are not having this one also, we are having In this cos square, cos cube gone. In denominator only we are left with sine and cos. Right?
Yes.
Okay, let's continue. Let me check the first one I have cancelled properly. Yeah, the first one we have cancelled properly. So the first one became tan x sec square x. You can see if you will be taking the tan x as a substitution, it will become simple, right? Right. Now the one of the question like this we were discussing that by making it a formula of sine 2x,